Hello students, now we are discussing the discovery of the proton. Already we discussed the last sessions we discussed the charge to mass ratio, discovery of the electrons and Mulliken oil drop experiment. After the Mulliken oil drop experiment, after the J.J. Thomson discovery of the electron, the scientist name is called as a Goldstein. The scientist name is called as a Goldstein. Performed the same discharge tube experiment several times, but the small modification. What is that modification? He used the same potential difference is same, but here the small changes. He has taken the perforated the cathode. He has taken perforated cathode in the sense the electrode, which is the electrode containing the small holes. That is the one change. Second one, this time he has taken the phosphorescent or fluorescent screen like that. That means zinc sulfide. He has taken behind of the cathode. He has taken. The process is same. Repeatedly he conducted the discharge tube experiment. After repeatedly conducting the discharge tube experiment, he observed that some reddish glow is observed behind of the cathode. That means what? Some rays are passing through the cathode and they are striking the walls of the discharge tube. Then only we can observe the reddish brown color. So, how we confirm that these are the positive rays? So, the rays are originated from the, not from the anode. Now, you can see that we know that cathode rays are whenever he apply the high voltage electron difference, gas molecule will be there. This gas molecule is ionized and releasing the electrons are they are releasing. Gas molecule, cathode, whatever the positive rays is there, this canal rays, this anode rays are the having the charges, positive charge. These are coming from the gas molecule. These rays are coming from the gas molecule, they are coming. So, when the gas molecule ionized, so hydrogens, when it is ionized, H plus and electrons, so H plus and electron, these positive rays are moving towards the opposite charges. Why? Because due to the electrostatic force of attraction, so these positive charge particles traveling towards the cathode and this electron moves towards the anode. Here he didn't kept the zinc sulfide screen, but he wants to identify the opposite of the negative charged particle. So whenever he applied the same discharge tube experiment several times, the gas molecule is ionized, the containing the positive rays are traveling and they are passing through the cathode. That's why these are called canal rays. They are coming from the anode. That's why these are called anode rays. We are calling. These are called. So whenever they are passing through the cathode, these canal rays striking the walls of the discharge tube. And he observed that reddish brown color he observed. So by this he confirmed that in the atom along with the negative charge to neutral atom, to make the neutral atom along with the negative charge, positive charge particles also present in a atom. So next, the scientist Rutherford named the hydrogen as a hydrogen nucleus as a proton. He named. Who named the hydrogen nucleus as a proton? Rutherford named the hydrogen nucleus as a proton. So now properties of the anode rays. Anode rays traveling in a straight line. These are the material particle. So, like the cathode rays, these are also traveling in a straight line. They are traveling. So here the gas molecule will be there. Gas is ionized. So electrons due to electrostatic force of attraction start moving towards the positive, and this hydrogen nucleus moves towards the electrode. So if you place the any material in the path of the canal rays or anode rays, they cast the shadow. So these are the rays. Whenever these are the rays, they are traveling in a straight line. So for example, if you place the any type of the material in their path, if you observe on the screen, you will get the this type of the material only I will get, like the X-rays. So this is what the path is a straight path. That's why they are showing the cast the particular material. Second one, you can see that anode rays are positively charged particle. So how we know that charged particle? So we know that like charges are repel with each other, opposite charges are attract with each other. So we know that here cathode is there, this end, here you can see positive charge, anode is there. Here gas molecule is ionized, so it will become H plus and electron will be there due to electrostatic force of attractions, high voltage difference, already some cathode rays is there, electron will get repulsion, this electron will come out, emitted, this gas molecule is emitted the electron, ionized, gas molecule is ionized. So you can see that H2 molecule is ionized into protons plus 2 electrons. This electron having the negative charge. Electron is attracted towards the positive charge due to electrostatic force of attraction. So electrons start moving the positive, and these positive charged particles start towards the anode. That means what? Opposite charges, they are moving towards the opposite charges. That means they must have the positive charges. Why? Because they are traveling towards the negative charge. If they are negative will get repulsion, but they are passing through the cathode. So that's why these are called as a canal rays. So they are coming from the anode. That's why this is also called as a anode rays. They are coming. So they are move towards the negative charge. That means they must have the opposite charged particle. What is the negative opposite? Negative opposite is a positive. So that means anode rays are positively charged particle. Of course, they are also having the kinetic energy. They will show the heating effect also. Next one, they affect the photographic flame. So when you pass the anode rays to the photographic plate, so it will become Ag and Br2. Next property, E by M value of these rays. These rays means positive rays having the value smaller than that of the E by M value of the electron. So now you can see that cathode rays E by M value and anode rays E by M value. So E by M value is also called as the charge to mass ratio or specific charge. So charge of electron is minus 1.6 into 10 to the power of minus 19 coulomb. Mass is equal 9.1 into 10 to the power of minus 28 grams. Okay, if you take this charge is plus 1.6 into 10 to the power of minus 19 coulomb. Mass is 1.672 into 10 to the power of minus 24 grams will be there. So by this only you can easily say that here numerator is same but denominator here having the high. So mass of the electron is negligible when we compare with the mass of the proton. Charge is similar, quantity is similar with the opposite sign only. But the problem is here it is having the negligible mass when compared to the anode. So obviously it is having the high value of the E by M value. Electron having the E by M value is high. Why? Because mass of the electron is very negligible when compared to the anode. Automatically we will get the E by M value of electron is more and E by M value of the proton or these rays are very less. The next property, E by M value is dependent on the nature of the gas taken in the discharge tube. So electron E by M ratio does not depend, independent upon the what type of the nature of the gas you are taking. But here this is only the one property is opposite of the electron. So this E by M ratio, if you take the gas, E by M ratio also will change according to the gas. So the thing, but E by M ratio changes with the changing of the gas in a discharge tube. So for example, you can take hydrogen gas is present. Hydrogen gas is this ionized into 2H plus 1 electron. So this means what? One hydrogen will giving the 1H plus 1 electron. If you see that, of course, mass is, if you see the E by M ratio of this proton, charge is how much? 1.6 into 10 to the power of minus 19. Mass, here only mass of hydrogen is 1. So 1.672 into 10 to the power of minus 24 grams. This is cool. Okay, this is one. For example, if I take the nitrogen gases, if I take the oxygen gases, everything it will be different. So hydrogen is converted into 2n atomic form, and nitrogen is giving n plus and electron it is giving. Okay, if you observe the E by M ratio, charge is similar. 1.6 into 10 to the power of minus 19 coulombs will be there. But whatever the mass, nitrogen containing the 7 protons it is containing. At the same time 7 electrons it is containing. So you can see that 7 into 1.672 into 10 to the power of minus 24 plus 1.672 into 10 to the power of minus 24 into 7. This is the mass. So 1.6 into 10 to the power of minus 19 coulombs upon the 14 into 1.672 into 10 to the power of minus 24. Hydrogen doesn't have the neutron, but nitrogen having the neutrons. Only proton is there, but when compared to the hydrogen, nitrogen having the more proton, nitrogen having the more mass, also automatically we will get the E by M value is different than that of the E by M value of the hydrogen. Okay, but E by M value of the hydrogen is maximum when compared to the other gases. Why? Because hydrogen gas, if you take E by M value of hydrogen, mass is small when compared to the other atoms. For example, if you take nitrogen, oxygen, fluorine, mass is more. So whenever the denominator is high, we will get the low value. Whenever the denominator is low, automatically we will get the high value. So hydrogen mass is very less when compared to the nitrogen mass. Automatically E by M value for the hydrogen will be maximum. That means mass will be low, automatically E by M will be small. So this is about the discovery of the proton. Now we got the mass of the electrons in grams or kg. How we will convert the mass of the proton in a AMU? So mass of the proton in AMU, you can see that mass of proton in grams is equal to 1.672 into 10 to the power of minus 24 grams. We know that 1 AMU is equal to 1.6 into 10 to the power of minus 24 grams. We want the mass of the protons in AMU. So mass of the proton in AMU, mass of proton in AMU, atomic mass unit. So 1.672 into 10 to the power of minus 24 grams upon the 1.6 into 10 to the power of minus 24 grams. So approximately we will get 1.00728. Approximate value is 1.00728 AMU. You will get the value. Mass of proton is related to that mass of the electron. So mass of proton, mass of electron. So mass of proton 1.00728 AMU. Mass of electron in AMU 0.000548 AMU. So 1836 times. Approximately 1836 times. It is heavier than that of that one. So we know that. So charge of electron minus 1.6 into 10 to the power of minus 19 coulomb. Mass of electron 9.1 into 10 to the power of minus 28 grams. Charge of proton is equal plus 1.6 into 10 to the power of minus 19 coulomb. Mass of proton in grams 1.672 into 10 to the power of minus 24 grams. Molar mass of proton. This means what? 1 mole of proton mass. 1 mole of proton mass proton mass in 1 mole. 1 mole in the sense how many particles? Generally, mass of proton is equal 1.672 into 10 to the power of minus 24 grams it is there. Mass of the proton. But here we want the 1 mole of the proton. 1 mole of the proton in the sense how many? 6.023 into 10 to the power of 23 protons mass. So mass of the proton 1 mole proton 1 mole proton mass 1.672 into 10 to the power of 24 6.023 into 10 to the power of 23 proton will get approximately 763 grams. So this is the mass of 1 mole of the proton. Radius of proton is equal 1.53 into 10 to the power of minus 15 centimeters. 1.53 into 10 to the power of minus 13 centimeters. So volume of proton is equal 4 by 3 pi r cube. So 4 by 3 pi r cube. So now you can do that 4 by 3. Already we know the volume of the radius. This is 3.143 into 1.53 into 10 to the power of minus 13 whole cube. So you will get the value approximately 1.5 into 10 to the power of, if you do the simplification, you will get the minus 38 centimeter cube. By this you can calculate that the density is equal mass by volume. We got the volume and mass we know. Volume is equal 1.5 into 10 to the power of minus 38 centimeter cube and the mass is equal 1.672 into 10 to the power of minus 24 grams. So this is about the discovery of the protons and properties of the canal rays. So next session we will discuss about the discovery of the protons and different type of the arrangement, that means atomic model, J.J. Thomson atomic model and Rutherford atomic model we will discuss. So thank you for watching.